Hello everyone, I hope you all are doing well. Welcome back to our AWS AI Engineer Essential series. My name is Dheeraj Choudhary, and in our previous video, we explored AI, machine learning, and generative AI, the technologies that are transforming the industries right now. But here's the reality: building and deploying AI isn't as simple as writing a few lines of code. There are massive challenges around infrastructure, cost, scalability, and complexity around building it. So, how do companies actually run AI at scale? That's where the cloud comes into picture. So, let's dive in. Let's start with the first major challenge in AI, the massive data requirements. Data is the fuel for AI, and modern models need enormous amount of it. ML model need thousands to millions of examples to learn effectively. A spam filter needs thousands of labeled emails. An image classifier needs millions of labeled images. Without sufficient data, models can't learn accurately the patterns and will perform poorly. So deep learning models need even more billions of data points. Neural network with billions of parameters require massive dataset to train properly. The more complex the model, the more data it demands to avoid overfitting and achieve good generalization. Storing petabytes of data is extremely expensive on your local servers. Hardware cost, cooling, maintenance, and redundancy adds up quickly. A single petabyte storage system can cost hundreds of thousands of dollars, not including ongoing operational expenses that would be separate. Data must be accessible, secure, and fast to retrieve. Training models require reading data repeatedly at high speeds. You also need backup systems, disaster recovery, encryption, and access control. Managing the infrastructure is complex and resource intensive. Here's the real example. Training GPT-3 required 45 terabytes of text data scraped from internet. That's an enormous amount of storage, and it all needs to be processed efficiently during training. Most organizations simply can't build and maintain this infrastructure in-house for sure. This creates a real world problem. Small and medium companies can't afford massive storage infrastructure. The capital expenditure and expertise required to build a data center puts AI out of reach for many organizations. This is where cloud storage becomes a game changer. The second major challenge is computing power. AI models, especially deep learning models, are incredibly computational intensive. Let's look at what it really takes to train them. Training deep learning model takes days or even weeks on regular computers. CPUs simply aren't built for the parallel computation neural network requires. What might take weeks on a CPU can be done in days or hours on GPUs. This is why AI requires extensive GPU, that is graphic processing units. So GPUs excel at parallel processing, performing thousands of calculations simultaneously. A high-end GPU like NVIDIA A100 cost between $10,000 to $12,000, and the newest H100 and H200 models can even cost more. So, but here's the catch. Large models need multiple GPUs working together. Training a complex model might require 8, 16, or even 256 GB GPUs in parallel. So the hardware cost alone can reach millions of dollars before you even start training your model. The real world numbers are staggering. Training a large language model can cost between 1 million and 10 million in compute resources. GPT-3 training cost was estimated between 1 million to 4.6 million depending on the calculation method. These are costs that only large tech companies can afford. This creates a massive barrier to entry. That is, small startups and research teams simply can't buy racks of $10,000 GPUs and maintain the infrastructure needed to run them. This is why cloud computing with on demand GPU access has become essential for democratizing AI development. The third major challenge is scalability and flexibility. AI workloads aren't cost, they have dramatically different resource needs at different stages. The training phase needs massive compute power. You are processing millions of examples through billions of parameters repeatedly. This is an extensive workload that demands maximum resources, multiple GPUs running at full capacity for days or weeks. Now, The inference phase has complete variable demand. Once you train your model, you are making predictions. Maybe you have 10 predictions per second during off hours, but 10,000 predictions per second during peak hours. The workload fluctuates dramatically based on the user demand. Traditional on-premise servers are fixed, they can't scale up or down dynamically. You buy hardware with specific capacity. If demand increases, you are stuck with slow performance. If demand drops, those expensive servers sit idle doing nothing for you. This means you are paying for idle resources when you are not actively training any model. If the training takes 2 weeks but you own the hardware year round, you are paying 50 weeks of idle GPUs. That's incredibly wasteful and expensive. Here's the real world problem. Over provisioning means wasted money. You buy enough capacity for peak demand, but most of the time it's underutilized. Under provisioning means slow performance. Your users experience delays and your model take too long to train. There is no good middle ground with fixed infrastructure. And that is where cloud's elastic scalability becomes critical. You can scale resources up during training and down during inference. You pay only for what you use and when you use. No idle resources, no wasted capacity. The fourth major challenge is model management and MLOps. So once you build a model, the work isn't done. Managing it in production is incredibly complex. The fourth major challenge is you have multiple model versions to track and deploy, different versions for testing, staging, and production, rollback versions if something goes wrong. Managing these versions across teams and environments manually is really a nightmare. You need to continuously monitor performance over time, like is there any accuracy drop, are predictions taking too long, are there any errors which are coming in. So without monitoring you won't know when something breaks until the user is going to complain by itself. Model degrades over time due to data drift. Data drift is when statistical characteristic of incoming data change from what the model was trained on. User behavior shifts, market conditions change, and suddenly your model's prediction becomes inaccurate. This means model need periodic retraining. You can't just deploy a model and forget it. You need automated pipelines to detect the drift, trigger retraining, and validate the new model and redeploy it for you. All this requires collaboration between data scientists, engineers, and operations team. Data scientists build the model, engineers deploy them, and operations team monitor them. Without proper tools and processes, communication breaks down and things fall through the cracks. Now, here's a real example. Netflix runs hundreds of machine learning models simultaneously for recommendations, thumbnail personalization, streaming quality, and more. Imagine managing all these models manually would be a chaos. Without proper MLOps tools, model management becomes completely unmanageable. Now that we understand the challenge, let's see why cloud computing is the perfect solution for AI. The cloud directly addresses every challenge that we have just discussed right now. So unlimited storage means you can store petabyte without buying the hardware. Cloud providers like AWS, Azure, and GCP offers virtually unlimited storage that scales automatically. You don't need to plan capacity, buy servers, or worry about running out of space. On demand compute lets you rent GPUs only when you need them. Training a model, spin up 16 GPUs for a week, then shut them down. You pay per hour of usage, not for idle hardware sitting in your data center. Auto scaling handles variable workload automatically. During peak inference training, your infrastructure scales up to handling 10,000 or more than that requests per second, and during off hours, it scales down to saves your cost. No manual intervention required, it's completely automatic. Managed services provide ready to use tools for model training, deployment, and monitoring. AWS SageMaker, Google Vertex AI, and Azure Machine Learning handle the infrastructure complexity for you. You focus on building models, not managing the servers. Now, global reach means you can deploy a model closer to users worldwide. Cloud providers have data centers in dozens of regions globally. Deploy your model in multiple locations for low latency and better user experience no matter where they are. The key benefit over here is pay only for what you use and scale instantly. No upfront capital expenditure, no idle resources, no capacity planning guesswork. This transforms AI from something only giants can afford into something accessible to startups and the individuals. Let's break down the specific benefit cloud computing brings to AI and machine learning workloads. These advantages are transforming how companies build and deploy AI. Cost efficiency is massive. There is no upfront hardware investment, no buying 10,000 GPUs or building data centers. Pay as you go pricing means you only pay for compute time and storage you actually use. Small teams can afford to train models that would have cost millions in infrastructure. Speed to market is dramatically faster. You can launch AI workload in minutes instead of waiting months for your hardware procurement, data center setup, and configuration. Spin up a GPU instance, start training, and iterate quickly. This agility is crucial in competitive markets. Access to latest technologies without buying it. Cloud providers constantly upgrade their GPU offerings like A100, H100, and the newest chip which is available in the market. You get access to the cutting edge hardware immediately without capital expenditure or worrying about absolute, not absolute, the one which is become old. Built-in security provides enterprise-grade protection and compliance. Cloud providers invest billions in security infrastructure, encryption, access controls, and compliance certifications. So you inherit this security without building it yourself. That comes in inherited by the cloud provider on which you are going to host your models or applications. Collaborations become seamless. Team work together on shared infrastructure with centralized data, models, and notebook. Data scientists in different locations can access the same resources, share experiments, and collaborate in real time. This breaks down silos and accelerate the development. Now let's explore AWS AI ML services. AWS provide a comprehensive suite of tools that address every challenge we just discussed. Let's break down the key services for you. Amazon SageMaker is the end-to-end machine learning platform for building, training, and deploying models. It handles everything from data preparation to model monitoring in production. SageMaker provides notebook, automated model training, MLOps pipeline, and deployment infrastructure, all fully managed for you. Amazon Bedrock gives you access to foundational models for generative AI and LLMs. You can use Claude, Llama, Stable Diffusion, and other top models through a single API. No need to train massive models yourself. Just use pre-trained models and customize them based on your needs. AWS AI services are pre-built AI capabilities that require no machine learning expertise, like Amazon recognition for image and video analysis, Amazon Comprehend for natural language processing, and Amazon Transcribe for speech to text, Amazon Poly for text to speech, and Amazon Textdoc for document extraction. There are n number of services. Don't worry, each one of them I am going to explain you with a project. Storage and compute infrastructure provides the foundation. Amazon S3 stores petabyte of training data with unlimited scalability. Amazon EC2 instances with GPUs and the latest technologies give you on-demand compute power for training the models. The key point, AWS provides everything needed for AI ML at any scale. Whether you are a startup training your first model or an enterprise managing hundreds of production models, AWS has the services, infrastructure, and managed tools to support you. Let's look at the real world example that brings everything together. Netflix is one of the world's largest streaming platform and they run their entire AI infrastructure on AWS. Netflix stored billions of viewing records in Amazon S3. Every play, pause, rewind, search, and rating from 230 million users worldwide is stored and analyzed. That's petabyte of data that would cost millions to store in their own data centers. These use Amazon EC2 instances with GPUs to train recommendation models. Netflix run hundreds of machine learning models for personalized recommendations, thumbnail selection, streaming quality optimization, and content discovery. Training this model requires massive GPU compute power that AWS provides on demand to Netflix. Amazon SageMaker powers their model deployment and A/B testing. Netflix constantly experiments with different models and strategies. SageMaker enables them to deploy new models, run A/B tests, monitor performance, and roll back changes if needed, all without managing the infrastructure. The infrastructure scales automatically to serve 230 million plus users globally. During peak hours, when millions watch simultaneously, AWS scales up. During off hours, it scales down. Netflix only pays for what they use, and users get low latency experiences worldwide. Netflix saves millions compared to building their own data centers. The capital expenditure, maintenance, staffing, and constant hardware upgrades would cost far more than their AWS bill. So, cloud enables them to focus on content and user experience instead of managing their own infrastructure. And the key takeaway over here is even massive company with huge budgets choose cloud for AI workloads. If Netflix trusts AWS with 230 million users and billions in revenue, that tells you everything about the cloud capabilities for AI at scale. The best part, you can start learning building with AWS AI right now without spending a dollar. Let me show you the easy way to get started. AWS free tier is available for learning and experimentation. New AWS customers get up to $200 in credits, $100 at sign up, and $100 more by completing onboarding activities. You can test drive AWS AML services for up to 6 months completely free. No hardware investment needed. Start with $0. Amazon SageMaker offers 250 hours per month of notebook instance for 2 months completely free. Amazon Recognition gives 5,000 image analysis per month for 12 months. Amazon Bedrock Credit lets you experiment with foundational models and LLMs. So learn SageMaker, Bedrock, and AI services in our upcoming tutorial. I will be creating hands-on tutorials showing training to deployment. Everything will be designed to work within the free tier limits. So build real projects using cloud infrastructure. The free tier isn't just for toy examples. You can prototype machine learning models, build image recognition apps, create chatbot with LLMs, and deploy production ready solutions. Perfect for your portfolio and learning real world cloud AI skills that you can showcase while you're searching out for AI engineering job. Wraps up our today's comprehensive video. If you enjoyed this video and want to keep learning step by step, make sure to like the video, subscribe to my channel, and hit the bell icon so you don't miss the upcoming tutorials. Thanks for watching, and I will see you in the next